Hello, I hope everything is going well with you. Uh, in previous session, I introduced distributed system. I talk about its definition, goals, benefit, and types of distributed systems. One type of distributed system is distributed computing system, which are used for high-performance computing tasks. Some instance of distributed computing system are cluster, grid, and cloud computing system. In the previous session, cluster computing was presented. Okay, now I'm going to talk about grid computing. Especially, I want to introduce economy grid, which is a new paradigm for grid computing or internet computing. Okay, a number of slides in this presentation are taken from Professor Buya's presentation. The agenda of this presentation includes computing platform, big barriers. Okay, after that I'm going to speak about toward global computing, how the grid is different, is the internet web, next generation internet. Okay, after that I want to introduce some type of applications for grid resource management issue, major grid project globals, grid architecture for computational economy, or GRACE is an important type of grid, and some economic models for resource trading, and after that, the grid resource broker, and conclusion is the final part of this presentation. Grand challenge applications are difficult but important problems which are needed for various institutions, organizations, and governments. These applications can solve using computer modeling, simulation, and analysis. For this purpose, high-performance computing is used. These type of applications require running on high-performance computing systems. Some type of these programs includes life science, aerospace, e-commerce applications, digital biology, military applications. These applications need high performance computing. This application can solve by computer modeling, yes, or simulations. Okay, in this figure, you can see the computing platform evolution. The desktop computer has minimal performance. The desktop computer has minimal performance compared to other systems. In this figure, you can see two dimensions. Performance dimension, and in another dimension you can see the evolution of computing platform. Okay, first type is desktop computer. After that you can see SMPs or supercomputers. SMP or symmetric multiprocessors offer high performance than desktops. SMP involves a multiprocessor computer hardware and software architecture where two or more identical processors are connected to a single shared main memory. Okay, you can see this architecture in these slides. Again, you can see some processor 1, 2, processor N, which are connected to a single shared main memory. This main memory is shared between all processors. Okay, the system bus is shared between all processors. Okay, and the processor have full access to all input and output devices and are controlled by a single operating system instance that treats all processors equally. Okay, and in another definition, SMP systems are tightly coupled multiprocessors with a pool of homogeneous processors running independently of each other. Each processor executing different program and working on different set of data has the capability of sharing common resources such as memory, I/O devices, interrupt system, and so on. Okay, that are connected using a system bus or